Hello guys, welcome back to Mr. Cloudbook channel. Today is the day 27 of the Kubernetes masterclass, and in this video we are going to discuss about the node selector. So I will explain a simple way. So this is important in the upcoming sessions. We will use at the node affinity and anti-affinity and everything. That's why I'm going to explain here. So first of all, what is a node? In Kubernetes, a node is a mission. Okay. So what we have? So let's use a one simple rectangle. So this is the Kubernetes cluster, and so you have one control plane. This is the control plane, and this is the one worker node. This is another one. This is the control plane. So here I'll write this is control plane. This is 01 worker node, and this is 02 worker node. Okay. So here you have to understand what is a node. A node is a mission. It could be a virtual or a physical server where your application pods are running. Okay, so each node have one label. Okay, so here we can see each node having different labels. Okay, like type equals to database, or here on your small worker node there will be a type equals to SSD type server, like that. Each one have label. Okay, this is one label on one node, and this is one label on the other node. Okay, so type equals to SSD and type equals to DB. So node have labels which are key value pairs that describe certain characteristics of the node. Okay, so this particular node, okay, whatever the 01 node, which will only support the database type of pods. Okay, and this is the second type of a worker node which supports only SSD type of a pods. Okay, so like which needs the highest CPU and highest RAM. So every pod will be placed on this particular second node. Okay, yeah, a node might have a label like type equals to SSD or a type equals to HDD to indicate that it's suited for this specific kind of workloads. Okay, so some pods will definitely requires the HDD, like highest CPU usage. At that time you need the SSD type of worker node. Okay, so here we need to talk about the pods as well. So here I have the simple pod. Okay, so this is one simple pod I have. So this is the DB type, and this is the SSD type. Okay, these are two are worker nodes. This is one worker node, and this is one worker node, and this is control plane and master node. Okay, so what is a pod? Pod is the smallest number of deployable unit in the Kubernetes. It contains your application such as web server or a database. When you create a pod, you might want it run only on only a specific nodes based on the labels. Okay, so this pod. Okay, so whatever the pod I'm using, okay, this is very high-end pod. Okay, the pod is requires high CPU usage. Okay, CPU usage is needed. So this pod needs the CPU usage. Okay, okay, here I have the high CPU usage. This is where high CPU usage is there. So you will add a one label to your worker node. Already you added a one label. That label is SSD, which is having the high CPU usage. So what you will do is you will call that label on your pod here. Okay, so you will add a node selector, and in that node selector you have to use this particular key pair. So whatever the key pair you are using, type, okay, equals to SSD. You have to add that into your pod, so that particular pod can be placed on your second worker node instead of your first worker node, because you are telling that I want this particular pod on the second worker node only. Okay, this is how node selector will work. Okay, so based on the requirement we will place that particular pod using that particular node selector. Okay, a node selector is a way to tell the Kubernetes I want this pod to run on only nodes that matches this specific label. Okay, so whatever the label, okay, this is the label. Okay, I am providing inside the pod, so it should match that particular label. Okay, whatever the label I am mentioning here inside the pod should match the label on my worker node. So there only place my pod. Otherwise, don't place. That is how I am telling. So with the help of the node selector. Okay. So Kubernetes uses this information to decide on which node we have to host that particular pod. Okay. So here this particular pod will be placed on my second node. Okay. So I have another pod, which is only need the simple CPU usage and everything. So what I did is I added only database here. Okay, DB label. So this particular pod will be placed on this particular node 01. This is how the node selector will help. Okay. So you have two nodes and one is having DB and one is having SSD. Okay, which is having which pod needs the ICP uses, it should be placed on the second worker node. So at that time you have to use the node selector and give type equals to SSD in that particular node selector specification, and I mean in the pod specification it will deploy that particular pod on that particular node. So this is how node selector will help. Okay. So how it will works, Kubernetes scheduler, when you create a simple pod, okay. So the Kubernetes scheduler will look at the available nodes in the cluster. First of all, it will look at the available cluster. First of all, it will do the filtering. Okay, this label or this worker node and that worker node. How many worker nodes will be there? So first of all, it will check the available nodes on your cluster, and then it will filter out. Okay, this is how much CPU it's using, how much CPU it's not using. So we have different kinds of workloads. Okay. So on worker node 1, we can use the small specification like 6 CPU RAM or 12 GB of RAM. That is up to you. CPU cores will be different for each node. Okay. On the first worker node, we will use a less kind of a 6 GB of CPU cores and 12 GB of RAM. On the second worker node, I am using 24 CPU cores and 48 GB of RAM. Okay. I'm simply explaining. So my one of my pod requires highest CPU. So that is having the SSD type. So what I will do is I will add a simple node selector specification in my pod YAML file. So it will deploy that particular node on my second work node, which is having the ICP usage. At that particular workload time, I have to use that particular node selector. Okay. So here Kubernetes scheduler will check for the available clusters, and then it will check the filter out the which is having the highest CPU available and memory available, and then it will check the label. Okay, so what is the label, is there any label attached on my pod or not? If it is attached, it will check the same label on my node as well. So if it's matched, then only it will place that particular pod on my Kubernetes worker node. Okay, so if it's a fine, how pod placement will be also possible. If it finds a node with the type equals to SSD label, so it will directly place that particular pod on my second worker node. Okay, if it's not found, okay, the label is not there on my worker node, what it will do? The pod remains in the pending state. Okay, until you have to set that particular label on your worker node. Okay, this is how it will works. Okay, so why we have to use a node selector means organizing the worker loads. Okay, for example, running the highest CPU usage, you need a GPU where kind of a application needs to be run. At that time, you need the particular node selector, which is mainly used for the organizing the workloads and optimizing the resources. Okay, some nodes might have a specific hardware or the specific software configurations required by the certain apps. At that time, you have to use the resources optimizingly. At that time, you have to use the node selector. Okay, separation at the node selectors we need to use for the separation also, keeping a certain workloads separate from the other for the security purposes or the performance reasons. At that time, you have to use the node selector. Okay. So let's go into the demo. So let's see kubectl get nodes here. So we have to see the labels also. Kubectl get nodes hyphen show labels. And you can see that we have different labels already attached to your Kubernetes control plane and for your node as well. So we have the different labels here. Okay. So what I will do is I will go here to the kubernetes.io and search for node select. Simple example, we will use it from here itself. So you can see here assigning pods to a nodes and node selector. This is the node labels we need to use. Okay. And you can say that like many other Kubernetes objects, nodes have labels. You can attach labels manually. Kubernetes populates a standard set of labels on all nodes and the cluster. Okay. So let's try to open it in the new tab. So you can say that kubectl get nodes hyphen show labels. Okay. So you want to label a node. Okay. Choose one of your nodes and I add a label to it. Okay. What I will do is I will do this one kubectl label nodes and your node name and disk type is SSD. Okay. So I'll copy this comment, come here, clear the screen. So I want to label the node 01. Okay. So because this is the node we are going to use, right? And which I want to label this one disk type as the SSD and enter. And you can say that node 01 is labeled. Okay. So what I will do is kubectl get node 01 hyphen show labels. Only I will checking for the node 01. Okay. Sorry. The server. Yeah, let's forget that one. So kubectl get node and node 01. And you can say that. So these are all the labels. Okay. Beta kubernetes.io. And here we added this one disk type SSD. Okay. So this is how you have to add the labels. And if you want to remove, you can remove as well. And you can see that node selector. Okay. Disk type SSD. So this is a simple deployment. Okay. You can see that this is a pod YAML file, API version, kind, metadata, name, labels, env. You can give this one. Okay. Just copy this one. I will explain there. So vi 1.yaml. I'll paste here. So we have this one easily. Everyone knows, right? API version, kind, pod, metadata, name, labels, spec, containers, image, and image policy. Just remove it. We don't need. And what we added is finally just this one node selector, and the disk type is SSD. So what it will do is we added one label, right? Let's come out of it. So cat 1.yaml. Sorry. Okay, let's clear the screen here, and I will so labels here and cat 1.yaml. And here, what is the disk type we are using? SSD. So in the node selector, you have to use disk type colon SSD. Okay. Here it's matching this one. Okay. Disk type SSD. So and if you apply kubectl apply -f 1.yaml, and you can see that pod nginx is created. If you get pods, okay, kubectl get pods -o wide, and you can say that it's placed on node 01. Okay. And if you describe it, okay, kubectl describe pod and give that pod name in the next one. And if you go up here, you can see it everything here itself. Describe, if you describe, you can get everything. Okay. And you can see that labels we provide env test. Name of that pod is nginx. Default namespace it's created. Okay. And you can see everything here. Okay. State running when it started like that. And you can see here everything type and the disk type here node selectors. You can see that node selectors. Okay. If you try to run, okay, kubectl run, I will run simple nginx image, nginx one hyphen image equals to nginx. Okay. See, it's created a node nginx one. Okay. I will directly describe it. Okay. I know the name kubectl describe pod nginx one nginx. Okay. Enter. And you can see that node selectors is none, right? But by default, it's created on your node. Okay. Hyphen o wait. See, in the next one is created on node 01. Okay, why that one? Because we have the taints applied. Okay, kubectl get nodes. See, this is net control plane and node 01. If you describe, okay, kubectl describe node. So control plane I will describe. And if you go up here little bit, there is a one field we have. Okay, see, dates. Okay, this is the one we have to see. So here we have no schedule is there. So that's why it's not able to schedule the pod on your control plane. Okay. And let's check here. Let's try to give direct command kubectl get nodes grep taints. Okay. Okay, it's not giving the value. Okay, no problem. Uh, but what I can do is I can remove that one. Okay, kubectl taint node control plane, and what is that taint we have? See, this is the taint for your control node. Just copy this completely. Okay, I copied it and I will paste it here and add hyphen. Okay, enter, and you can see that it's untainted. Okay, so if you see again, describe node control plane, and if you go up a little bit, and you can see here taints none. Okay, and you can see it's control plane. Okay, name is control plane. We removed the taint. Okay, so I will add one label. Okay, so kubectl label node control plane. Sorry, control plane. What is it? Type equals to HDD. Okay, so you can say that node is labeled. Okay, I have one label. Okay, kubectl. Okay, get node control plane hyphen show hyphen labels. And if you see here, okay, we have the type here. Type HDD is added. Okay, for your control plane. So if I create one particular node, okay, vi nginx 2.yaml, I'll just copy this one. Okay, directly here, paste it. So here in the node selector only you have to change. Okay, last time we provided the directly type HDD. Okay, this image we don't need. Node selector means so we are directly telling that particular label. Okay, so type whatever the type which is matching HDD, place this pod on that particular node only. Okay. So if you apply kubectl apply hyphen f nginx 2.yaml, and you can see that nginx okay. And if you see here taints and tolerations, we have to check. Okay, taints is none. Okay, that is fine. Labels type HTTP is there. Let's check what is the issue. vi nginx 2.yaml node selector image nginx. Okay, let's change the name maybe to 1. Okay, I'll come out of it and let's try to apply kubectl apply hyphen f nginx 2.yaml. It's saying warning. Okay, automatically pod nginx is invalid. Let's see kubectl pods. Okay, it's great. Okay, nginx 1 is there already. Okay, that's why maybe issue. Okay, let's try to edit nginx 2. Let's try to set up a 2 here. Name is 2. Okay, so let's apply it kubectl apply hyphen f nginx 2.yaml. Okay, you can see that it's created nginx. And if you see kubectl get pods hyphen o wide, and you can see that it's creating on control plane now because which is matching the label HDD. Okay, it's still under creating. Now it's created. You can see that control plane because it is matching the label. Okay, HDD. Okay, if you describe kubectl, let's clear the screen. So kubectl get pods, and if you describe this one, last time we didn't provide the exact name because nginx and nginx 1 is taking. That's why we are facing issue. Okay, kubectl describe pod and give that one. And if you see here, okay, node selector type equals to HDD. Okay, and where it's placed, and you can see it here as well. Okay, node control plane, it's placed on control plane. Okay, so because we have the labels attached on worker node, we added the disk type SSD. On the control plane, we added the type equals to HDD. So I used the node selector so to place my node directly. Okay, this is how you have to use. Okay, so if you see here add nginx 2 and I use it type HTTP, so which is having that particular label on my control plane. And if you see cat1.yaml, so which is having disk type SSD on my worker node. Okay, that's why this particular pod is placed on the my worker node, and HDD which is having label on my control plane. This particular pod is placed on the control plane. Okay, so this is how node selector will help. We will use this node selector in the upcoming sessions. That's why I explained how to use the node selectors and everything. And hope you understand the video about the node selector. And thanks for watching the video and keep on supporting to Mr. Cloudbook channel.